Welcome back, students. In this video, we're going to cover Lesson 2-4, Transformations in the Plane. So we're talking, of course, about the coordinate plane. Standards for this particular lesson are GR 2.2. I can identify transformations that do or do not preserve distance/angle measure. And GR 2.1, connecting benchmark, I can describe and represent rigid transformations. So basically, GR2 is the math, 2.2 is the math, 2.1 is the actual graphing. So there you go. All right. So key vocabulary. Give me just a moment. We'll write this in as I talk, or I'll do the word talk and then move. Hang on, let's see. Okay, so a transformation is a function that takes points as inputs and gives others as outputs. So the problem will give you a set of coordinates, those are the inputs, and the answer you give is the output. So that's after we do these rules. Now, the notes do not have those rules, but I've printed up a reference sheet. I sent it to everyone in Focus, and I'm going to pass out copies tomorrow during class, so you guys can keep it in your binder. But unfortunately, it's not something we can use during the EOC, and it's not included on the reference sheet, but it is something that we will be using all year, and we'll learn and do our best to memorize as well as we can. Okay, so now next word. Sorry, I should have been writing, and instead I was talking. All right, so in a transformation, the pre-image is mapped onto the image. So the pre-image is what you start with, and the image is what you end with. Just keep that in mind, because the text, our books, our test, all that stuff is gonna. So when I refer to the text, that's kind of what I mean. Anyway, it's going to begin to refer to the pre-image and image, and you have to know that pre-image is obviously before image. So it's not an after, but it is the end point is the image. Okay, let me just write these words in. Okay, so a rigid transformation, also known as isometry, is a transformation that preserves distance and angle measure. So what that's saying is that the shape, when it moves, the angles won't change because the sides are going to stay the same. It says distance, it really means side length. So like down here, this triangle and this triangle, they're congruent. They're the same. It's rotated, but we'll get to that in a minute. And this is also pre-image, image. So as I'm continuing to teach. Okay, so a reflection or a flip is a transformation that's in a line called the line of reflection. Most of the time, it's going to say you're going to reflect in the X or the Y axis. Later on, we'll get into some stuff that's a little more complicated, where we'll use a different line. It'll be X equals 2 or Y equals 3, and that's not the origin, that's a different line, so it changes things. But for now, just know that it's a line of reflection, but for the most part, it's going to be like that. So it's going to be the axis for the most part for us, at least for a little while. All right, so number 2, a translation or a slide. That is a transformation that moves all points of the original figure the same distance in the same direction. So it slides over. So like right here, this is the same, this is the same. It's, well, here we get into English, but it's slid, or it's going to slide over. So it's going to go to the right. 1, 2, 3, 4, 5, and up. These are probably 2, so that's maybe 10. Sorry. So if these count 2, we're going to say this is in between, which is 1. Or we can call it a half. Let's just rewind. delete the last couple of sentences. So 1, 2, 3, 4, 5 up and a half. I'm sorry, 5 to the right, a half up, but that's a slide. It slid 5 and up a half. Okay, and now number 3, excuse me. A rotation or a turn is a transformation about a fixed point. That's the center of rotation. For now, it's going to be the origin, 0, 0, right here in the middle. Later, it'll get more complicated because we'll change that, but it's going to rotate. So notice this is not a reflection. This thing is not standing the same way. This is a rotation. It rotated, and if it moves down, it's going to point. It moves down here, it would point down. Gets over here, it's going to point to the left, and by the time it gets back here, it points up. So it goes up, right, down, left, up, right, down, left. That's how that rotation works. And of course, the other way, up, left, down, right, up, left, down, right. And these two are the same. So apologies there. So let's do these, and then I'm going to show you the reference sheet that I've created that you guys will see tomorrow. So if you missed 2-4 today, then tomorrow when you come in, you'll get 2-4, you'll get the reference sheet, you'll be all caught up, and then when you watch the video, this will all make sense. But example 2, so parts A, B, and C, the D is the check for you guys. The problem is D is the same as C, so it's a freebie. So we're going to scoot the paper up. So example 2 and example 2 checks, A, B, C, and D. Identify the type of rigid transformation shown as a reflection, translation, or rotation. So it says rigid transformation because it hasn't, the angles haven't changed and the sides haven't changed. So I already told you over here, this one slid, or translation or slide. So this slid or translated. Either way, it's translation. See, again, you guys need to be happy I'm teaching you math and not trying to teach you English, because, bro, we got some problems. All right, and I noticed, so the copy, and of course, I can't print in color because I'm poor, and if you mention this in class, you heard me say I was poor because I can't print color, then I'll give you 5 bonus points just to see who's listening. But part B here, so this was in color, and it made a little more sense than the way we're looking at it. This is a reflection, so I'm going to make one side purple, and obviously if you painted your, so for those of you wearing makeup, if you put, say, not mascara, see, obvious I don't wear makeup, but the stuff over your eyelids. Anyway, if you were to say color that purple, if you're looking in the mirror, obviously if you blink it better be purple. If it's not, you are in a scary movie. But for our case, we're going to make them different colors because that was what was intended in the original copy, and it kind of helps when it's, instead of being blank or white. So this little crescent moon is reflected, and of course I'm looking at this and I don't know that I can tell in the screen. Hopefully the YouTube video looks better than the little monitor I'm looking at. But so this is reflected across. So over here, I've already mentioned this is a rotation. So again, I'm just going to write this. See the arrow, or the vertex here, one of the angles of the triangle is pointing up here. So it's point up here. It's right there. It's going to be down here because it rotates. And it's going to be left over here, like this, and like this. So I hope that helps with the rotation thing. I try to show in class. I use different figures. It's harder to do it on the camera. So hopefully that helps. And of course, C and D are the same. So, right, up, right, down, left, up, left, down, right. And of course, this way is counterclockwise. I'm just going to say CCW. And then this way, the way the clock turns, is clockwise. Just as a little refresher, Not saying some folks have had problems in the past. Anyway, so over to the reference sheet very quickly before we go here. And we'll go back and forth between the reference sheet because these two examples, they're both reflections in the X and the Y over here for my example that I'm going to show you guys. And then the one you work is going to be just the X-axis. So I'm going to show you the rule on the reference sheet, and then I'm going to write it here before we work my side. And then I'll write it over here for you guys. So you pause and work that, you're good before you go to the other side of the paper, because there's the next two have the next example, and the final two have the final formula we're working with. So there'll be those two more chances to pause if you need to. So, all right, so geometry transformations reference sheet. So we're going to start here because reflections is next. Nope, I'm sorry. Reflections is what we're doing. Rotations is next. Sorry, I'm going to lie to you guys. I used AI. Remember what I told you. AI doesn't do your homework for you. It helps make your homework better. So this was all my stuff, but it formatted it. It just didn't, I didn't tell it. I didn't give it a specific order. Okay, so reflections. So when we go over the X-axis, X comma Y. Now this is what the problem gives you. Everybody gets so bent out of shape over letters and math, and I get it. But for this purpose, so if the problem says that the point's 3, 2, and we're going to reflect over the y-axis. So the y-axis says that we're going to make the x negative and keep the y the same. So in that case, for the y-axis, 3, 2 would be negative 3, 2, because x comma y became negative x comma y. So we kept them in the same place, but we changed the x to negative. We took the opposite. So just remember this, it's negative, but it's telling you to take the opposite. All right, so that's why negative x is negative 3 when x was 3. I'm hoping this helps. So we're not really going to talk in this lesson about these two. I just included them because they're part of this information, and you guys are going to keep it in your binder. But for now, X and Y. So if it's over the X-axis, we're going to make the Y negative. They're going to stay in the same spot, but the Y is going to be the opposite of what it's supposed to be. And if we go over the Y-axis, we're going to take the negative X. So if we reflect over X, we take the opposite Y. If we reflect over Y, we take the opposite X. But they stay in the same. Okay? All right. Ready to break. So let me write this little rule. So X-axis is the negative Y. Y-axis is the negative X. But they stay the same. Okay? Hopefully this helps. I'm trying. Okay. All right. Example 3 says triangle ABC has coordinates, and it gives us those coordinates, and we're about to go ahead and plot our points. And I'm going to go a little slow. Just, I know some of you folks, don't be embarrassed if you need to come talk to me or whatever, but some of us get a little bit backwards on the plotting, and I get it. I am almost 50 years old, and it's taken teaching this class a couple of years for me to get good at it. So it's okay. There's no judgment here, and good I use with quotations. You can't see me saying that, but I understand your struggles. So we're going to scooch, hold on, back up a little bit, there we go. All right, so part A, well, first let's plot our original triangle. So I'm going to make it this blue. Again, I can't tell. I'm hoping. I look at it in person and it's fine. I look at it on the screen and it's like gray. So hopefully you guys can see it. So our original point. So A is at 3, 2. So our X is left and right. Our Y is up and down. If it's positive, it's right and up or up. If it's negative, it's left or down. So these are both positive. So we're going to the right 3, 1, 2, 3, and up 2, 1, 2. Draw the point. So again, we go right 3, 1, 2, 3, and then up 2, 1, 2. Because positive is right and up. Positive is right and up, and negative. So positive, and then negative is left or down. So, all right, B. Positive 2, negative 2. So we're going to go to the right 2, 1, 2, but we're going to go down because it's negative 2. So negative 1, negative 2. All right, and C is positive 4. So let's go 1, 2, 3, 4. And then I'm looking while I'm holding the point, and it's negative 5. So I'm going down 5. 1, 2, 3, 4, 5. Okay. All right, well, I don't have my ruler or anything else, so we're using this little Cinemark card. That's where I take my girls and go see movies. And I say the girls because I'm not playing video games unless it's them. I like the little grab machine. I like stuffies. I don't know if you guys call them stuffies. That's something my kids say. We said stuffed animals when I was, but anyway. I may try to use those, try to get those from the claw machine, but other than that, I'm not interested. I didn't mean to color that in, but it's okay. So this is where we start. So this is triangle ABC. All right, so part A. So I'm going to change to a, let me think. Let's try this. It's, hold on, let's do this. Okay. So part A, we're going to make purple, and they want to know what the vertices or the coordinates are for the image. So the next step, remember this is the pre-image, after a reflection in the x-axis. So I'm going to just do purple. So we will write down here. Let's take our points. Let's just write them. I'll write them first. So A was 3, 2, B 2, negative 2, and C is 4, negative 5. Whoops, 4, negative 5. All right, so this was our pre-image. This is our image. Now in a minute, part B, our image will become our pre-image because it's the next step in the problem. Don't get it confused. It's just we start here, then part A ends here, part B begins here, so it's the pre-image, and then we'll have another set of numbers. So all right, so now I'm gonna do orange for the next step. So we're going x-axis. X-axis says that x comma y becomes x comma negative y. So 3, 2 is going to become, so x-axis, x stays the same, so 3, and then negative y, so 2 becomes negative 2. Okay, B. And this is prime. We won't talk about this yet, but I'd like to get in the habit of you guys writing it. So this is B. This is B prime. So this is the pre-image, image, and then when we go over here, it's just going to be B prime prime. Don't worry, we're not going to say that all the time, or we would be saying prime half a class for the next couple of weeks. All right, so B, x stays the same. So 2 stays 2. The y, we're taking the opposite, the negative. So it's -2 over here. -2 becomes +2. All right, so C, x stays the same. So let's see, prime. See, I wrote it wrong just because. So x stays the same. 4 stays 4. -5, we want the opposite because the x-axis. So -5 becomes +5. All right, so let's plot those points. All right, so +3, -2. So we're going to go over 3, and these are going to overlap, you see, because it's a reflection in the x-axis or this line. All right, so +3, -2. I'm going to try to make this so we can see it. That's why I didn't want to color it in. I was going to try to be fancy, but, you know, clearly it doesn't work for me. All right, B is at +2, +2 now. It was at +2, -2, but now it's 2 to the right, 2 up. All right, last 4, 5. So +4, +5. We were +4, -5. So +4, +5. So 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. All right, back to the arcade at the movie theater. If you guys go to that one. Let's see. All right, so I'm just gonna color the out here so you can see it goes into here. I'm gonna make the very tip kind of dark. That was kind of what I was trying to get fancy with, but now it just looks like a big blob. But so our triangle here is where we started, and our triangle here, so we reflected. If you notice, there's just a little bit over here. There's just a little bit of the blue over here, so just a little bit of orange. And as an Alabama fan, I'm not a big, this orange-blue stuff. I don't know why I do it. Anyway, so we got just as much orange over this side as blue we have the other side. And any of you Gator fans want to give me heck about that, we'll give you some bonus points for that. I can't double up, but I can, maybe you weren't listening a minute ago. You're listening now. All right, so now, so it wanted the coordinates. These are the coordinates. This is how it flips. So think of this as like a paper football. Actually, let me just, no, I don't have any of the index cards here, but if we take, say this, okay, if we reflect it over this line, so let's say it's sticking up this much, when I flip it over, that much of the other side is sticking up, so that it's reflected. It's like when you look in the mirror. If I blink my left eye, the guy in the mirror, it's going to be his right eye because he's backwards. I may have just confused you worse. I need to hush. All right, so now, part B. Reflect, saying reflect ABC in the y-axis. Maybe they wanted it here in class. We have done, I've been doing it from here, like making this the new coordinates. We can do both if you want. I'll make it this color again for this one, but I'm going to reflect this guy as green, or we may, I don't know. Well, if I can remember not to color it in, how about that? All right, so we started there. So from here, so this is your x comma y. We want to go in the y-axis, so the x is going to change, the y is going to stay the same, but they're going to be in the same place. So 3 becomes -3, and then the -2 stays the same. 2 becomes -2, the back 2 stays the same, because -x, so comma y. All right, then in here, 4 becomes -4. 5 is y, it stays the same. Now, just in case, say this was negative, because it wants the negative, it would be positive over here. But because this is positive, we're taking the opposite. So I'm just trying to reiterate that. All right, so here's our new 3 points. So we'll do it over there. And actually, this video is going kind of long, so never mind the other. Just do it. We're doing it from here. If you guys want to practice, then do this same thing with these 3 points, and you'll get this guy. And because it's reflected in this, you'll notice it's 2 away. Actually, you know what? Do the math, but watch this. So this is 2 from it. So 1, 2. I'm not even going to draw it. This is 1, 2, 3, 4. I'm going to go 1, 2, 3, 4 over here. And then this one is 1, 2, 3. I'm going to go 1, 2, 3. I will do the lines, but you do the points. I mean, obviously you can look, but you see it's reflected. It's like you kick the paper airplane. Not paper airplane, paper football. Shoot. All right, so now let's just draw the green. You'll see how this will look because they're both reflected. So -3, -2. So -1, -2, -3, up 2. See, this is where. Oh no, it's going to be because it's here. That's the flip. Sorry, -2, -2. Wait a minute. Oh. Well, anyway. All right, and then -4, -5. 1, 2, 3. Sorry. So this should be green, and it's because. I mean, I counted, but it was I forgot this was the original. This was down here. So you see those points, it lines up. So we'll just make it green. But if you wanted to do that up here, do the math, take these and use this, and then count. Well, wait a minute. No, I started out trying to do this, and I moved over here because I'm crazy. So yeah. Count from the 3, not from here. From this point, and from this point. So it's that many away, that many away, that many away, and it should match up because that's what a reflection is. Okay, moving on. Sorry, long-winded tonight. Example 3 check. So you guys are going to take the coordinates and you're just reflecting it in the x-axis. So you're going to use this. So just to help. And they want a B, C, or D. I would like for you to plot it. If you're comfortable doing that and you can just do the math and kick it out to me and know which one of these it is, go for it. But your x comma y is x comma -y because of we're reflecting the x-axis. Okay, let's flip over. Okay. All right, so back to the page here. Well, first let me just point out what we're doing. Hang on 1 second. Okay, sorry about that. All right. So it's gonna example 4 for quadrilateral QRST. It gives us the coordinates. You're going to find the coordinates of the vertices after a translation along vector. This new pencil. So a translation along vector 7, 7,1. Okay. I'm going to put the paper down to translations. I have to pause. Explain later. Well, anyway, I have to pause. Be back in just a minute. And we will start from translations. All right, so translations. A translation slides a figure without rotating or flipping it along a vector. Now, a vector, you notice that these are not parentheses, they're the pointy kind. The numbers in here is represented AB. It's A is going to be the same as X. It's going to be left, right, and B is going to be up, down. So what you end up doing to translate along a vector, because you're sliding, you're scooting, you could be moving then, I'm sorry, right then up or left then down, but it ends up being a move that's not exactly straight. Or it can be, depending on these numbers. Excuse me, I'm sorry. So the rule x comma y, so what you start with, you add a to x. So adding if it's a positive number. If it's negative, you're subtracting it, but it has to be written plus a, and then y plus b. So whatever x is, say, well, here's our example. So your example, x comma y, let's say that we're going to move a vector 3 comma negative 2. So it's 3 to the right because that's a positive number, and 2 down because that's a negative number. Remember, positive is right and up, negative is left and down. So in order to move 3 units to the right, 2 down, you would add the 3 and subtract 2 from your xy. So let's just use the example up here, your point 3, 2. I don't have a regular pencil. That's all right. That's okay. So let's just assume we're using x comma y, so 3 comma 2. So over here, so if our point we're using is 3, 2. So it'd be x is 3, so 3 plus 3. 3 plus 3, so your new x is 6. And then y minus 2, y is 2, so 2 minus 2, 2 minus 2 is 0. So your new point from 3, 2, if you were moving to the right 3 and down 2, would be 6 comma 0. And it's because, so you went down 2. If you were 2 above the line and you dropped 2, you're on that x-axis. So I hope that helps. I will write this on the paper as I flip over. Okay. On the video that went on longer than I expected, but I hope you guys are getting something out of it. If you are, please let me know in class. I mean, you can do it in the comments, but it's not about like YouTube stuff. It's more about, getting us to the EOC and passing it. It has nothing to do with YouTube. YouTube's only to get it to you guys. All right, so example 4. So we got QRST. We're going to translate it along vector 7, 1. So what that looks like, because it's AB 7, 1. So x comma y becomes, and I'm going to just move it down here, x plus 7, because they're both positive, y plus 1. Hopefully you can see that. All right, because that's positive, 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 positive. So how it looks, let's go ahead and plot our original QRST. We'll make it purple. All right, so negative 8, negative 2. So I can tell you this guy's going to be down here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the left because it's negative 8, and then we're going to go 2 down, 1, 2, because it's negative 2. All right, next point. R, negative 9, so I know this was 8. I'm just going to go over 1. You're welcome to count, but this was 8, so 1 more is 9, and then negative 5, so down 5. 1, 2, 3, 4, 5. All right, next point, negative 4, negative 7. So we'll just go back to counting 1, 2, 3, 4, and then negative 7, 1, 2, 3, 4, 5, 6, 7. Excuse me. All right, last point, T, negative 4, negative 2. So again, they're all negative. So this is the negative negative land. This is the positive positive land. Over here you have a negative x but a positive y because it's left but it's up, and then down here you have a positive x but a negative y because it's to the right but it's down. I have a little anchor chart in the class. I'll show you guys. Okay, so last point, -4. Sorry, I forgot to mark it. 2, 3, 4, -2, 1, 2. All right, back to Cinemark. I think the last movie we saw, Superman. Before that was Thunderbolts. Not that y'all asked, but before that was Lilo and Stitch, I think, at the beginning of the summer, because Sadie loves Stitch. That's her favorite Disney character. Okay, so this is where we start. Now, let's try to write smaller but legibly. I know that's way difficult. So we're going to do the math. Actually, now I'll do it right here. All right, so our first point, Q is -8, -2. So we're going to add 7 to -8. So -8 plus 7 is going to be -1. So there's the 1, and then under it all, I know it's a lot of writing. All right, then we're adding 1 to this, so -2. I'll just kind of -2 plus 1. -2 plus 1. Hopefully that's terrible, but -2 plus 1 makes -1. So our first point is -1, -1. Probably not going to write all 4 of these. We're going to have to do some math as we go. We're not showing everything. I'm not sure. I'm trying to make this work. So the new Q is -1, -1. So let's make it red, because why not? Why haven't we been doing red? So -1, -1. So again, this guy's going 7 to the right and 1 over. So our Q started -8, -2. So we should be able to count from here to here should be 7 over and 1 up. So let's look. I'm not going to make that in red. Let's do it. I'm afraid that that yellow won't be visible. The white definitely won't be. Let's just use this pink. So from this point, this is Q. And this is Q prime, the new Q, after we moved it 7 and 1. So let's count. So 1, 2, 3, 4, 5. Uh-oh. I'm in trouble. Is this negative? Hold on. -1, -2, 3, 4, 5, 6, 7, 8. Yeah, so what am I doing? Red spots in the wrong place. Good Lord. -1, -1. I just went over 2. See, this is what happens when you don't pay attention. Okay. Well, see, and this is also why we double check, because this is what happens. It's also what happens when I'm trying to grill and trying to teach at the same time. So my bad. All right, so starting from here to here, forget this. So 1, 2, 3, 4, 5, 6, 7. So 7 to the right, and then 1 up. 1. Okay, so it should be like that for all of them. We can draw them in pink and then color them in red as we use the math. But so like from here, so 7 over 1, 2, 3, 4, 5, 6, 7, and then 1 up puts you right here. So this would be that point. So then we go 7 over from here. So 1, 2, 3, 4, 5, 6, 7, and then 1 up. So that guy's going to end up here. And then lastly, this one. 1, 2, 3, 4, 5, 6, 7, 1 up. Puts this guy here. So let's see if these line up. We got the first one, but let's see if the other ones. I hope it looks better on YouTube, because it all looks gray to me. Or maybe, well, no, it looks in color here. But anyway, so let's go to the next point. Let's do it in the red pen. All right, so point -9 r. So r was -9, -5. So we're going to do this math here together. So -9 plus 7. So we're going closer to 0, right? We're going to the right. So the new r prime, -9 plus +7 is -2. And then what was the other? -5. So -5 going up 1 would be -4, right? And I think you guys had showed me or were using some sort of box method for the midpoint. You may have something for this that you guys have done, and I'm open to anything that you know before that helps you know this, because I can pass it along to others and we can all win together. Again, for anybody watching or actually listening. Okay, so r prime, -2, -4. So let's go, wait a minute. It's something. Oh no, that'll be that point. Okay. Whew, got lost a minute. This is what I get for not trusting the math. All right, -2, so over 1 over 2 and then down 4. 1, 2, 3. Wait, God, I can't see now. Over 2 and then down 1, 2. Sorry, trying to look at the screen. 3, 4. Trying to be the magician here and let you see that there's nothing up my sleeve. And I was also making sure I wasn't going to miss the spot, because it's hard to video and watch and stuff. I don't know. And you guys good with this sort of thing? I'm up for any suggestions, just because, I don't edit. I do it and upload it and go. It's just here for you guys. So any, obviously be kind. I mean, don't tell me how awful I am. Maybe just say that, maybe be encouraging. How about that? Anyway, let's go. So S is -4, -7. But no, I do welcome any, advice. There's a couple of videos, if you go back last year, that have no sound, and if my son hadn't taken the time to listen and give me some pointers, I wouldn't have known that the microphone was not properly connected or something. I forget what it was. Anyway, so S, -4, -7. So we're going to the right 7. So we're going past 0, because -4 plus +7, or plus 7, excuse me, the S prime is going to be +3. -7 going up 1. So from here you go up 1, it's -6. Let's just go ahead and do, pick a different color. I gotta speed this along. T. -4, -2. So adding again, so -4 over here when it went up 7, it went to +3. So T prime is +3, and then -2 going up 1 goes to -1. Sorry, I wrote, 3's right. I'm looking at that 4 and confusing myself. So let's plot these last 2 points. So +3, so 1, 2, 3, -6, 1, 2, 3, 4, 5, 6, and then lastly +3, 1, 2, 3, -1. So there you go. So now we can color it in. Hopefully it looks a little better than before. You guys are much better at this. I didn't even use my card that time, so it looks even worse. Did you see? So we scooted to the right 7, up 1. Over here, just highlight you. So your vector is +5, -3. So you're going to go, so your x comma y is going to be x plus 5, because it was a +5, and y -3, because it was a -3. So as you take these points, you're adding 5, subtracting 3, adding 5, subtracting 3, adding 5, subtracting 3. So plot it before and after, and there you go. So let me quickly do this last one because the video went way long. But we got one more example, and I should have split this, but it's okay. All right, so last one, we're doing rotations. So quickly look, rotations up here at the top. A rotation, it turns a figure about a fixed point, usually the origin. For now, it'll be the origin, and yeah, so rotations are around the origin unless otherwise stated. Later on, that'll be different, but for now, this is what we're doing. So if you notice 90 clockwise, so remember clockwise is this way, counterclockwise is that way. So the way the clock turns is clockwise, against the way the clock turns, or backwards is counterclockwise. But notice, so 90 clockwise, so if we go one space, because remember the coordinate grid is 4. So if we go 1 to the right, that's the same as going 1, 2, 3 to the left. So that's why these are the same. That's why these are the same. Going 90 left is the same as going 270. Let's start here. So over here, so over 1 is the same as going 1, 2, 3 the other way. So when you go, when it's here, so x comma y becomes y comma negative x. So you would flip your x and y, and your x, you would take the opposite sign. I'll show an example for each down here. When it's 180, so 180 halfway across is the same as halfway across, so it's always this way. So x comma y becomes negative x comma negative y. So x and y stay in the same spot, but they both take the opposite sign. And then lastly, the 270 clockwise or 90 counterclockwise, it puts you x comma y puts you negative y comma x. So again, rotations are around the origin unless otherwise stated. So your example. So 3, 2, because it's negative x, negative y, 3, 2 becomes negative 3, negative 2. So, and then 270 clockwise. So 270 clockwise over here, negative y x. So your 3, 2, the 2 is going to go up front because it's the y, but it becomes a negative. Did I mess that up? I haven't printed for everybody yet, so maybe I didn't mess it up. Hold on, that's the negative y. Yeah, negative y, sorry. Comma, positive x. X stays the same. So x went from the front to the back, y came forward but took on a negative. If it had been negative, it would have become positive. So just like we said here, that negative actually means the opposite. So we take the opposite sign. All right, back to this. So, last one. I'm going to plot these points quickly. If you need help plotting points, please let me know. So that's 2, 3, 4, 5, 6, 7, 1. All right, 6. Go back 1 and then down 3. 1, 2, 3. And then 1, negative 3. 1, 2, 3. Trusty video game pass thing. Totally skipped that out. All right. Just need to bring the compass and protractor home like I'm supposed to. All right, so there's where we start. And they want to rotate 180 degrees. So this will be easy. So F is 2, 1. So 180, we write this over here instead. So 180 x comma y becomes negative x comma negative y. All right, so we're just going to take the opposite. So f prime is going to be negative 2, negative 1. G was 7, 1. G prime, that's what we'll say later. We haven't really gotten into it, but again, I'm trying to get you guys in the habit. So we're going to take the opposite. So positive 7 becomes negative 7. Positive 1 becomes negative 1. Sorry, I did those in the same color again, trying to finish. This video is super long, and I'm super sorry. 6, negative 3. So H prime. Positive 6 becomes negative 6. Negative 3 becomes positive 3. So we just took the opposite of both. And J, lastly. Did it again. So, oops. So 1, comma, negative 3. So J prime is going to be negative 1, comma, positive 3. All right, so let's plot these very quickly, and I'll do them in purple. So negative 2, negative 1, negative 7, so 2, 3, 4, 5, 6, 7, negative 1. Hope it was negative 1, I'm not looking. Yes. Negative 6, so back 1 and up 3, 1, 2, 3. Oh, this is starting to look. And then lastly, negative 1, up 3, 1, 2, 3. All right, let's just quickly. If you notice the way I had to turn the card, so you see this guy's flipped. So if he's like this over here, because it would go from here to 90 to 180, so it's the exact opposite, and then 270s down here because you have to end up back where you started. So notice that there. Flipping down here, the practice you guys have, if you missed, let me know. I've got those with the keeping them with the notes. So finishing off real quick, the summary. So rigid transformations, they preserve angle measure, and this was in the very beginning, like 2 hours ago for those of you watching. And, sorry, I wrote over and, distance, which, just so we are clear, is side length. It means that the shape doesn't change, it doesn't get bigger or smaller. We do that later and it's called something else, but for now. But rigid transformations, they preserve these things, so your shape stays the same. It may flip, it may turn, it may rotate, and it may scoot, but it doesn't change size. Number 2, how are reflections and rotations different from translations? I'll let you guys tell me the difference. What's the difference between when it rotates, when it reflects, and when it just scoots or slides or translates? All right, until next time. Have a good night.